So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as map transformations. So map transformation is about the exact locations when we are transforming from 3D to 2D. So in the previous lecture we have learned about what are the different types of projections and how we transform the 3D information to the 2D information without losing its properties. So here in the map transformation, what are the different locations, what are the control points we are going to assign, what is latitude, what is longitude, that all we are going to discuss in this lecture now. So let us start with the contents what we are going to discuss today. So map transformation, control points, georeferencing, latitude, longitude, GCPs. So these are all the contents we are going to discuss today. So first of all, map transformation is after the projections, we have assigned the projection, like we have assigned the latitude and longitude from the 3D to the 2D world. Now after assigning to the 2D map, we are going to transform this information into map transformations. So map transformation is a geometric transformation, is the process of using a set of control points and transformation equations or to register a digitized map, satellite image or an aerial photograph onto a projected coordinate system. So transformation is a process of assigning the control points. What are the control points we can say? How do we assign the control points? Suppose this is the map. So GIS transformation process using a set of control points and transformation equation. Now to register a digitized map. So suppose this is our digitized map, means we have this vector map. So we have a vector map. Now here we have different types of features information here. So we have a building here. Now you have a road here. Okay, road here. You have a water body, you have a forest boundary, water body, building. Okay, so this all information, if you want to assign the transformation, or if you want to assign the control points, so we need to register the map. First of all, register the map to a digitized map, satellite map or a photograph, or onto a projected coordinate system. So after projection, we have to just make it as projected coordinate system, so that it will fix the locations. Wherever the points should exactly fit, it will fit to its position. So in GIS, geometric transformation includes map to map transformation and image to image transformation. So map to map transformation and image to image transformation, I'll just tell you what is that. So map to map transformation is like, suppose if you have a topo sheet map here, okay, this topo sheet map, if you want, it is having its latitude and longitude locations. Already locations are provided here. So latitude, like x and y coordinates are assigned, x and y coordinates are assigned. So on the topo sheet, first of all, we georeference the topo sheet. So georeference the topo sheet and we just run the georeferencing process and we assign the control points. So after assigning the control points, this map is georeferenced. So now what happens if this map is georeferenced? So how to transform it to the satellite? Okay. So this is like map 1. Now here map 2. Map 2 is the satellite. So transforming the information from map 1 to map 2. So whatever location is here, suppose this road is there, if you want to put the location, same location, what we have to do is, in this satellite map, you have to put one point here as a GCP and put one point here in the satellite as a GCP. So map to map transformation means putting the same point in the topo sheet map 1, putting the same point in the map 2 satellite. So as many points we put here, this point, this point, this point, this point, that points will be transferred here So as it is transferred. The information whatever it is present in the topo sheet will be transferred to the satellite data. So this is called as map to map transformation. Now if you talk about this map to map transformation and image to image transformation, now suppose this is the satellite. So if you want to georeference the other satellite, if you want to assign the GCP value to the other satellite, so GCP is nothing but it's a ground control point. So whatever points, wherever we sit, wherever you stand, there is a particular control point for each location. So that point location should be transferred exactly to the map. So if you want to do from map to map, so this is satellite map, for example map 2. Now if you have a map 3, this is map 3. So same thing if you want to transfer. So same point, what we are going to do is put the same point here, put the same point here, same point, whatever points we put here, automatically the software will be taking its location from map to map. So this is called as map to map or image to image. Okay, so this is called as map transformation. So now control points. So GCP are defined as the points on the surface of the earth known location used as georeference. So ground control points is GCP is a feature that you can clearly identify in the raw image which you have known as the ground coordinates. So this ground control points can be easily identified. So it's like a point. Control points are the points which we assign it here by x and y coordinates. So this coordinates we have to assign here. So x and y coordinates is latitude and longitude. So we are assigning both latitude and longitude to the map feature. So this is called as the GCP. We are assigning the point, we are assigning the location to the map feature to find out the exact reference from the earth surface. So GCP is a feature that you can clearly identify in the raw image for which you can know ground coordinates. So control points for an image to make the transformation to map transformation is also called ground control points, are the points where both image coordinates and real world coordinates can be identified. So GCP are real world coordinates. So here you have a real world. So this coordinate if you want to assign here. So suppose here is a ground control point, actual GCP. So it is recorded by the GPS device. Okay. So same thing should be transformed to 2D. Okay, same thing should be transformed to 2D, and this real world coordinates can be identified. The GCP are selected directly from a satellite image. The selection is not as straightforward as selecting photics for the digitized map. Geometric transformation is the process of using a set of control points and transformation equations to register a digitized map. So geometric transformation or map transformation is assigning the control points basically. So suppose you have a map like this. So what you want to do, this is the raw map. Now if you want to assign the GCPs, that is ground control point. So if you are assigning the GCP, that is called as georeferencing. Means we are assigning the reference point to the map now. So what we are going to do, we are assigning the point here, 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 here. So we put some 4 points here to control the map, to control the map. So these points are not simply we are keeping, we are just keeping this point here and we are going to assign the x, y. So x value we are assigning, y value we are assigning. So latitude and longitude we are assigning. So x is longitude, y is latitude. So these two values we are assigning on this point. Then the second point we'll take, this is point 1, this is point 2. Now the third point, point 3. Now the fourth point, point 4. So 4 points we have here. So all the 4 points we are going to assign the x, y, x, y, x, y. Okay, so all the 4 points we are putting on the coordinate system, and then we are putting the latitude and longitude values and then run the georeference. Okay, run the georeferencing to get your map registered, to get your map transformed, to get your map as a geometrically corrected map. Okay, so satellite image or an air photo is to be projected coordinate system. So here these two things can be georeferenced like this: satellite image or an aerial photo to a projection coordinate system. Now georeferencing, as I just now told you, so georeferencing is the process of assigning real world coordinate to each pixel of the raster. So in the previous slide you have seen, we have assigned this xy value, xy, 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 x and y. So here you have 4 points. So once you provide this latitude and longitude, so once you provide these points and assign the x and y value, and we run the process, then what happens? The real world coordinates are assigned. So real world coordinates are assigned directly to the map. Okay. So once you put these 4 points, 1, 2, 3, 4, what happens? The map is controlled. With the help of the 4 points, the map is controlled. That means the pixel will take the value. Okay. So once it is taking here in the 4 corners, automatically this whole map will be georeferenced. Okay. So many times these coordinates are obtained by the doing field surveys, collecting coordinates with the GPS device for few easily identified features in the image or map. So how to collect this points, GCP points? To collect the GCP points, we have a GPS device. So if you don't know the GCP point of any kind of location on the map, just you have to use the GPS device. You have to just go and stand at that particular location, whichever you need to assign in the map, and then you have to record the latitude and longitude of that position. So number of satellites which are on work for the GPS, providing the GPS information, which is in the space, they are working to get the information in the GPS device. So this information is from the real world data, and then it is transformed to the 2D map, and then it is assigned to the map. Now it is that process, and another process is like directly we take the topo sheet map. So on the topo sheet map, already the information of points, the coordinates are given in the map. So that coordinates, what we do is, and that coordinates if you want to assign on the map, then what generally we do is, we just scan the map, we input in the GIS system, just we enter the points and we assign the x and y coordinates, and we try to control the entire map. So once the map is controlled, the assigning of the coordinates is assigned to all the pixels in the map. So wherever you move the cursor, it will show the map is having the x and y value. Each pixel will be having the x and y value. Okay. Now latitude. What is latitude? So latitude is the angular distance measured north to south. Okay. So we just say x and y, right? So y is latitude, x is the longitude. So generally the angular distance measured from north to south or north to south is called as latitude. So the equator is 0 degree. As you go north of equator, the latitude increases. So as you go north, the latitude increases increases all the way up to 90 degrees at the south pole. So 0 degrees to 90. So suppose here is your 0 degree. So you go up to north, 0, 20, 40, 60, 80, 90. Or else if you take 10 difference, the interval will take for 10, 20, 30, 40, 50, 60, 70, 80, 90. So 90 degrees north. Now here south, if you want to go from the equator, so clearly I will make you understand. Okay. So here is your angle. Okay. So this is the equator. equator, 0 degrees we say. So 0 degrees north. So this is north, this is south, east, west. So here 0, 10, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70 degrees, 80 degrees and 90 degrees. So 90 degrees south from the equator. Now 90 degrees north from the equator. So here 10, 20, 30, 40, 50, 60, 70, 80 and 90 degrees north. So north and south is called as latitude. Okay. Now this is the north pole. This is the south pole. Okay. Now next, if you see longitude, so x-axis, it is the angular distance measured east and west of the prime meridian. So the prime meridian is 0 degrees longitude, and as you go east from prime meridian, the longitude increases to 180 degrees. As you go west from the prime meridian, the longitude increases to 180 degrees. So it is about like this angular distance from east to west. Okay, east to west. When we talk about east to west, so here you have this prime meridian, 0 degrees prime meridian. This is 0. We call it as 0 degrees. So here is like angles or the graticules, we can say. So here we have to go till 180 degrees. So like 20, 40, 60, 80, okay, 100, 120, 140, 160, 180, okay, 180 east. Now here we have to go 180 west, 20, 40, 60, we have 80, 100, we have 100, then you have 120, 140, 160, 180. So 80 degree west, 80 degree east. So this is called as longitude. Okay, as you go west from the prime meridian, the longitude increases to 180 degrees. Okay. Now GCP, ground control points, are defined as the points on the surface of the earth of the known location used to georeference. Okay, GCP we have already discussed. So a ground control point is a feature that is clearly identified in a raw image for which you have known to the ground coordinates. So ground coordinates can come from a variety of sources such as global positioning system. So global positioning system is the GPS device. It is used to collect the GCP points. GCP's point. Okay, ground survey, geocoded images and topographic maps are the different sources, you can say, sources of GCPs. Okay, sources of GCPs. So ground surveys means through ground survey, by taking the device, you can go to the ground surface and just find out the location wherever you need the ground control points. Geocoded image is like this is the geocoded image. Already the image wherever the locations are assigned, that can be used for the GCP points again to collect the information. And then you have topographic map. Topographic map, it is very easy way of collecting the information, because in the topographic map, if you see in the topographic map, already the GCP points are assigned. Already the latitude and longitude is assigned. So it is easy to collect the information from the topographic maps. Now geocoded images are the photos or images that have associated geographical coordinates, latitude and longitude, embedded with their metadata. So metadata, if you remember, that is the data about the data. So these images will be having geographical coordinates, latitude and longitude embedded with their metadata. So this geolocation metadata allows the image to be mapped to the specific location on the Earth's surface. Geocoded images are useful in the various applications like topographic maps, also known as topo maps, are detailed, accurate representations of natural and human-made features on the Earth's surface. So these maps use contour lines to depict the three-dimensional shape and elevation of terrain, providing valuable information for the various purposes. Now here if you see georeferencing, which we have discussed what is georeferencing. So georeferencing is assigning the information to the map. So this is the topo sheet map. This is also topo sheet map. So you can see in this map you have this location here. So how to assign? So this map will be having the reference points already. So with the help of the software, the x and y coordinates are assigned to the map, and then it is the process is done. The GPS process is done for assigning the coordinates to the map is called as georeferencing, right? So this is how it looks like. So here is one point. So like this, the map will be having 4 corners. So each corner it will be having 1, 2, 3, 4. So each corner will be having a latitude and longitude. So this is the 78 degrees 45 minutes is what? Longitude. This is the x-axis. 9. This is 17 degrees 30 minutes. So this is y-axis. So why it is y-axis and x-axis? Now 78 degrees 45 minutes is here in this point. Now as we move west, this direction, so you may find 78 degrees. Let us say if you go west, 40 minutes. Okay, 40 minutes. 70 degrees, 40 minutes. Now you will be having one more 70 degrees, 35 minutes. So like this you have 78 degrees 45 minutes here. Again 78 degrees 40 minutes, 78 degrees 35 minutes. Like this it will be reducing till 0. Okay. Like this here we have this 17 degrees 30 minutes y-axis. Y-axis is 17 degrees 30 up and down. North and south it will go. 17 degrees 30 minutes. Again you will be finding 17 degrees 25 minutes. Again if you go up 17 degrees 20 minutes. So 20 minutes interval is there. If you go up 20 minutes, if you go down again 17:30, again you have 17:30, 17:25, 17:20. Okay, like this up and down, north and south, it will be assigned. So assigning the latitude and longitude. So in the software we assign it. So if you put the point over here, so it will ask you the x coordinate and the y coordinates. As you assign the x coordinate and the y coordinate, so it will be fixed here. The location will be fixed on the map. Okay. Now here is the GCP point. It will look like this is the point we are assigning here. So this point once you give, it will give a box like this. So here it will ask you the x coordinate and y coordinate. Okay. So this once you assign on the map, then your map will be georeferenced. So this is about the today's lecture about the map transformations. So map transformation is transforming the real world coordinates to the 2D map, right? 3D to the 2D map. So transforming the georeferencing, the reference point to the 2D map, like whatever reference we provide, latitude and longitude should be transferred to the map, because while scanning there is no coordinates on the map. So once we see after scanning the data is converted to raster, later we assign the coordinates to the map. So like that we transform the information from 2D to 3D to 2D. Okay, so transforming through GCPs, collecting the GCP point through GPS device or through ground surveys or through topo sheets, that all information we transforms to the map. So once you assign on the map, the data is called as georeferenced map. So georeferenced map is fitting to its exact position. Okay, exact position means assigning the location to its position is called as georeferencing or assigning the GCP points. So these are the few references you can go through for finding out the more content, okay, about the georeferencing or map transformations, right? So you can just go through this contents references to find out the more information about it. So I hope you understood about the map transformation. We assign the coordinates to the map, 3D map to the 2D map by GPS device, finding out the locations and assigning on the map through the software, or directly we just assign through the GPS device on the map. From map to map we transform, topo sheet to map we transform, or directly from device we transform to the map. Okay, so that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.